let's practice integrating both indefinite integrals, as this one is, and we will do some definite, and most will involve substitution. This, if you look at this problem, is very natural to think substitution. At least the easiest way to do this is substitution, because here you see a function is raised to a power, and here this is 2x is the derivative of the inside function. This should make you think substitution. Okay, so I am going to write out all of the steps. So first here we need u, which is our inside function. Then we must calculate du, and du is, it's the derivative of this function times dx, and this has derivative 2x. Now, if you do not see this here, maybe for this first one I will actually rewrite. You can rewrite to where you group everything not involving u. You know, here this is u to the 9, right? Everything else we group with the dx. Okay, now the next step is, well, you see we have exactly du. So we convert the entire integral to one of u. This is a u to the 9, and then we have du. And then we integrate with respect to u. U to the 10th over 10 plus c. Finally, we go back to our original variable, which in this case is x. So we have 7 plus x squared to the 10th over 10 plus c. It's very important, as I have said in class, that you never see x's mixed with u's in any of these integrals. This is only u's and with respect to u, only x's and with respect to x. And then, okay, here is our final answer. Here's the next one. This is a definite integral, and again, substitution, because, well, this may not look like substitution so much. However, one of the places we look for an inside function is in the denominator, because we know, for instance, if you integrate 1 over x dx, it's ln, absolute value of x. This is one of the places we look for an inside function, and if we do take this, you see, because the derivative of cosine is negative sine, we see a multiple of the derivative in the integrand. Okay, this suggests substitution. Now this is a definite integral. It takes a little bit more. I will convert my bounds to u bounds, as I always do, but here u is 2 plus cosine x. Okay, then du. This is negative sine x dx. Okay, now we are not in the situation of the last problem where we have exactly du. We do not have exactly what we have. So we have 3 sine x dx, which is, well, if you move from here to here, it is a times negative 3 du. Okay, so handed to us in our integral, this is minus 3 du. Okay, and then now I will convert my bounds. When x equals pi, u is 2 plus the cosine of pi. The cosine of pi, well, if you don't remember, you can draw a picture. Pi is here. Cosine of pi minus 1. 2 minus 1, 1. When x equals 2 pi, u is 2 plus the cosine of 2 pi. That's here. The cosine of 2 pi, positive 1, which is 3. Okay, now let's do, so maybe I'll put a box around all of this. This was all of my work to convert this integral to an integral of u. Okay, now here we go. It's an integral. It goes from u equals 1 to u equals 3, and I have 1 over u times minus 3 du. Okay? You notice again, I have no x's here. This is u, du, okay? Then I have negative 3 ln, absolute value of u, evaluated between 1 and 3. You notice in this case, because I have changed my bounds to u bounds, I do not have to go back to x. Then I have minus 3 ln of 3, negative and negative becomes a plus 3 ln of 1. ln of 1 is 0, and so I am left with negative 3 ln of 3. And this is my final answer. Here is an indefinite integral. There is no one substitution for this whole problem. In fact, when I look at this first term, you should really think inverse sine, the arc sine. And here you see a tangent. The derivative of tangent is secant squared. Okay, so maybe there's a substitution on this term. Well, in fact, there is. So first, we want to break this into a sum of two integrals. Like this. And now, very nice, because only on this one am I going to do a substitution. So just for this integral, maybe I'll put little dots like this. We have u is the tangent of t, and then du, the derivative of tangent, secant squared t dt. Okay, so this is exactly what we have. We have u du. Okay, we don't have to compute the multiplier. Now we can go on to the next step. When I integrate this, I get 2 sine inverse of t. You could also write the arc sine of t. And then minus, this is an integral, this is u du. And that's the entire integral. We see u and then du. Okay, now we have 2 sine inverse of t minus, we have u squared over 2 plus c. And then our final step here, we must go back to t, our original variable. Sine inverse of t minus, this will be the tangent of t squared over 2 plus c. This is another definite integral. Well, you see this substitution also, because look what we see. We see the natural log, okay, off the top of our heads, from Calc 1 at least. We do not have an antiderivative for the natural log, but we also see a over x, and the derivative of ln x is 1 over x. So this very much lends itself to substitution. Okay, so here we go. Well, if I take u to be ln x, then du is 1 over x dx, which is exactly what we have. Now, I will change my bounds. Always I do when I am doing a definite integral using substitution. So when x equals e squared, u is ln of e squared, which is 2. And then when x equals e cubed, u is ln of e cubed, which is 3. Again, if you want, you can put all of this in a box. This is all my work to convert the integral to an integral entirely of u. And this becomes, the integral goes from 2 to 3. And then I have a u du. No longer do you see any logs or exponentials in this once I have made this conversion to u. And I do not need to go back to x because these bounds are u bounds. We integrate and evaluate from 2 to 3. We get 3 squared 9/2 minus 4/2, which is 5/2. This will be my final integral. Again, this is substitution and it's definite, okay? So let us do all of the work to convert this to something of u. You see here, we see this inside function, 2w plus 1. So u is 2w minus 1. du is 2dw. Now, we have just dw here. This will be 1/2 du. So when we convert, I do this every time I use substitution. Every single piece of my integral gets changed to something of u. And in particular, this piece, which is the dw, I will convert or substitute, the name substitution, with 1/2 du. Okay, one more step before I write the next integral that this is equal to is I will convert my bounds. When w equals 1, u is 2 minus 1, which is 1. When w equals 2, u is 4 minus 1, which is 3. Okay? This is all my work. Now, I have an integral. U goes from 1 to 3, and then I have a u to the minus 2 times 1/2 du. Every piece of my integral is now u. U. These are u bounds. I have no w's anywhere. Okay, then here we go. 1/2. We add a power, divide by the higher power, evaluated between 1 and 3. Maybe before I evaluate, I will simplify this a little bit. So this is, it's negative 1 over 2u, evaluated from 1 to 3. This is easier to work with. Then when I evaluate at 3, I get negative 1 over 6. And then I have a minus, which becomes a plus. I have 1/2. This is 3/6 minus 1/6. This is 2/6 or 1 over 3. This is our final answer.